So we are live. Okay, so this is the syllabus of this class. You should have seen this already. So the final exam date is the 15th, which is a Monday. It's 2 weeks from today. The final exam time is from 8 to 10 o'clock, but I'm not going to have a final exam for this class, so don't worry, there won't be a final exam where I'll test you on every single concept that we have talked about in this class. We talked about a lot of stuff, okay? And it's kind of unreasonable in a way to expect you guys to be able to answer those questions or write programs to demonstrate those concepts in just 2 hours. Because at work, you typically have a little bit more time and you can look up resources or collaborate with your peers to get complex stuff done. So instead, what we're going to do, some people will hate this even more than the final exam. It's like, come on, just give me a final exam. I don't want the other one. So here is, right there. Okay, so final project and grading, okay. We'll skip to the presentation part first. So in place of a final exam, we'll use a part of that time. It won't take up the entire 2 hours because we only have 8 enrolled students left, which means that each person can potentially take up 15 minutes. And I don't want to put a burden on you guys to talk 15 minutes about your own project and whatnot. So I'm still deciding on how much time for each person to present the project. So the idea of your presentation is to sell your app, is to tell your class about your app, what it is for, what kind of features does it have, what are the plans for its future, do a quick demonstration of what it can do, and just kind of wrap it up. Just like sales, it's a spiel for your app. Okay, so if you are to sell your app, how are you going to sell it? That's basically the presentation. I will not be grading on the usual things in the speech class, okay, like, how well do you articulate, how professionals are your slides, and so on and so forth. Hopefully, you won't be using much slides, okay? You'll be using your app and talking about it, okay? So are there any questions about that part? That on the final exam date, we are going to have we'll have a presentation of your final project. Okay, no questions. Cool. So we're going to get back to the grading part. So this is how your final project is going to be graded. It's a pretty good portion of your grade. We do have some other minor homework assignments here, but the final project is the big part. So for each part, it's going to be rubric based. In other words, I'm not just going to randomly pick a number and throw that number into your grade. For each item in the rubric, the general idea is anyone who's not turning in any work or the submitted work does not demonstrate whatever objective I'm trying to assess is going to get a 0. Okay, so I cannot see any proof or any demonstration that that particular objective has been achieved, and as a result, it is a 0. And on the other end of the spectrum, if the submitted work is perfect in the sense of I can clearly see that the objective has been achieved and it is overachieved, then it's a 4. So in the middle is a 2, which is kind of a C grade, is that the submitted work has some major flaws or it is very minimalist, but it still sufficiently demonstrates whatever objective I'm trying to assess it is achieved. Okay, but it's very minimal. Okay, if somebody just did it just for the sake of meeting this minimum requirement. Okay, and then we have the 1s and the 3s, which are kind of in betweens. So 1 means somebody turned in something, but it does not sufficiently demonstrate that the objective has been achieved. And then the 3 is somewhere between a 2 and a 3, which is basically kind of a B grade. And to me, a B grade means something is sufficiently done, it is not minimalist, but yet it is not surpassing expectations. And A is something that is surpassing expectations. So are we okay so far in terms of how I look at the point values? And by the way, these are also mapping to directly mapping to GPAs. So a GPA of F is a 0, GPA of a D is a 1, a C is a 2, a B is a 3, and an A is a 4. So I'm just directly mapping my point values to the GPAs. Yep.
Quick question, what day do we turn our project in?
On the final exam date.
So we'll drop it, we'll give you the source code, and we'll present our.
Right.
Makes sense.
I can potentially make it later, like you can turn,
Right,
you
it
can
should
fine
be
tune the
done by
code
then.
even more.
If I'm showing it off, it should be done. Unless I like incorporated comments.
Well, unless you work for certain companies, where they will demonstrate something to be done, but it's not really done. They only show you the parts that are done.
I worked at, that's a side thing, but I worked at Northrop for a while.
Okay.
And they showed off this embedded system, but we really had a cable hooked up to the backs.
So it's tethered.
It was bad. It was bad.
Okay, so these are the objectives. The objectives are copied directly from the SLOs, or the student learning objectives. So here's the objective. So this one is exactly quoted from the SLO of this class, which is to develop procedural logic for mobile applications. And as a result, I give you an example of what a zero means. A zero means there's no control structure. So, when the button is clicked, there's an assignment statement corresponding to it. Okay? A one means all the control structures are way too simple. There's simple single-level conditional statements, for example. Okay, any type of single-level control structure is too simple. Okay, I'm expecting you guys to be able to do nested control structures. So if you use nested control structures, you're guaranteed at least 2 points out of 4. If you want to get 3 points, you have to use some quote-unquote trickier control structures like throw and catch. Now, depending on what your program does, certain types of Android features must use throw and catch, must use exception handling. Okay, so it's not really that difficult to get to number 3. Okay, and then number 4 is the use of mobile-specific or user interface-specific control structures that involve non-blocking calls and callbacks to continue operations. If you use anything, when one call is just starting an operation, but when the method returns, it's not done, and later on you have to use a callback of some kind to say that, oh, okay, now it's done, I can continue to do something, that will qualify for 4. Okay, I don't think it's going to be very difficult for an app to get to the number 4 part.
Not in Android.
Not in Android. Just about any code in Android that is meaningful, it's going to be at least 3 or 4. Next one, synthesize object-oriented class structure to organize components of mobile applications. So a zero means, no human-generated subclass derivation. In other words, a particular app is only using whatever Android Studio is generated as code. Okay, so that does not count. One means minimal subclass derivation that does not serve any purpose other than, here, I have a subclass, but I don't even have objects of that subclass, or the subclass does not have any specialization. It just says, my subclass extends the superclass.
Here's my constructor.
Yep. But even with the constructor, you have to say super, right? 2 means a subclass derivation that is purposeful from existing Android classes. So 2 should not be very difficult to meet. Okay, so if you derive any subclass from a superclass that is applied by Android and you specialize a part of it, that qualifies for number 2, for 2 points. 3 points mean multi-level subclasses that are purposeful from existing Android classes. So you have subclass and the subclass thereof.
Is that an interclass in the subclass?
Yep. I might change some of these things too if you want to kind of add and go, what about this? Okay, and put it into one of these levels. A 4 means a custom non-Android class and subclasses thereof to specialize behavior. So if you create your own class, so it's not coming from the Android hierarchy at all, and it is useful, and you derive subclasses of that thing, that will be a 4. Because you're creating a class from scratch. Is that okay?
Create the class and then you want us to subclass it?
Yeah, well, maybe I would remove the subclass part of it. Yeah, because if you derive your own class, that means it's.
Only time I would subclass is because I had multiple instances of variations that.
True. Yeah, I might change that. Evaluate correctness and efficiency of mobile applications. A 0 means an app that does not work at all, because that would basically mean it is not correct and the person who's turning in cannot evaluate correctness. 1 means the app works, but not to the point where it will serve any purpose. Okay, so there's a splash screen and the main screen, but you've pressed any button, doesn't do a single thing. Okay, the 2 means an app that marginally works to get the main use cases done, but otherwise it is Spartan and or buggy. So it barely gets the bare minimum working, but it's not going to be doing anything more than that.
Buggy
so
does not mean crashing. It just means.
Oh, it can be crashing.
Means crashing?
It can crash, except even when it does crash, it will still get the main use cases done. Okay, so if the purpose of that thing is, let's say, currency conversion. Okay, so if I want to know how many yens is a US dollar, I click the button, it shows the number, and it says it'll continue, and I press the continue, it crashes. It will still serve the main purpose. But that would be a 2 out of 4 points. Okay. A 3 means an app that works to get all the use cases done and is relatively bugless, which means I can still spot problems with the app. And 4 means it is polished with great efficiency and is bugless. Now, it's going to use bugless and also getting all the use cases done as the main criteria, but if you want to polish it, make it look nice, that's good too. We are talking about the grading criteria for the final project.
Okay.
Yeah, but I have been streaming, so you can actually watch that too. This is for analyzing programming problems, which is basically saying I cannot tell whether a student can analyze programming problems unless the app has some kind of complexity. A 0 means an app is too trivial, involving no logic of any kind. 1 means the app is trivial with minimal need to analyze, does not utilize any topics introduced in class and demonstrated in sample programs. Okay, which is really hard to get to that point, because we have a counter app, right? Remember the counter app? It just increments a counter. It doesn't have any conditional statement of any kind. That will get you a 2. To get a 1 is pretty hard. A 2 means an app that is marginally complex, using 1 or 2 topics introduced in class and demonstrated in sample programs. Yeah, I think it's pretty easy to get a 2, okay? But that's just my opinion.
Put a list view in there, and I put.
A list view is all the way down there somewhere. A 3 means an app that is complex, using 3 or more topics introduced in class and demonstrated in sample programs. And a 4 means an app that is exceedingly complex, using 3 or more topics introduced in class and at least 1 complex Android programming concept that is not even introduced in class or demonstrated in sample programs. So that's something that you did some research on and go like, oh, so this is how we do da 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 da. Okay. For example, the use of your power conservation approach to your app, that will qualify. And if you use multi-layer animation, that will qualify as well, because I did not write an app that uses multiple layers to do animation. But if you do it like, oh, okay, I have 1 layer for the background, 1 layer for the main character, and so on, that will qualify already for 4 points out of 4. Formulate object-oriented solutions to mobile programming problems. 0 means no use of inheritance interface or any object-oriented programming techniques. 1 means insufficient use of object-oriented programming techniques. 2 means barely sufficient, which means inheritance of interfaces, inheritance of classes, interfaces, and anonymous classes. Those are pretty much, we use these in almost every single program. Every single time you want to say, I want this button to do da da da, you need to supply an anonymous class, or one way to do it is to supply an anonymous class to the on-click listener, set on-click listener method of a button. A 3 means sufficient use of object-oriented programming techniques, all the previous techniques plus some specific scope control. So anytime you say, oh, this is final, okay, this is protected, this is public, pretty hard not to use those things, okay? if you derive any subclasses, you'll be using those things. Number 4 is 4 points means the use of advanced object-oriented programming techniques, all the previous, plus at least one trickier concept like a singleton class. You define your own singleton class, the use of abstract class or polymorphism, or something like that. If you use anything that is not on this list, let me know and I'll kind of put it into the right category. Identify various types of processes on a mobile platform. This one is kind of hard for me because it's, on one hand, we talked about this stuff a lot, but on the other hand, since I did not give you this rubric ahead of time, you might have written programs that may not be using one of these things. So I'm kind of flexible on this one as far as how to place these components. But as it is right now, a 0 means there's no use of threads, intents, or callbacks. Now, callbacks are pretty hard to avoid. Anytime you use set on-click listener, it is a callback. It uses a callback, and most of the time it uses in anonymous classes as well. So it meets several requirements all at the same time. And if you put any control structure inside that callback that has a nested control structure, that meets that other requirement as well. So it's pretty hard not to get to that point. 1 means only use callbacks. 2 means the use of callbacks and at least one thread or intent. So the intent in this case includes starting a second screen of the same app. Okay, because that you also use an intent for that purpose. So any app that is multiple screen is automatically going to have probably callbacks and also intent at meeting 2 out of 4 points. 3 means more advanced use of thread involving synchronization amongst the threads or intent. Now, when I say synchronization amongst the threads, it also includes the use of post. So you basically use one thread and say, I need to draw something on the screen, but since I'm not the main thread, I cannot do that. I'm going to do a post to the handler of the other thing and say that, hey, I need to do something. This is what I want to do. Go ahead and do it for me. So we have that concept already talked about in class. And 4 basically just means a combination of these things. Okay, if you have any combination of callbacks, threads, and or intents, any type of these things interacting together, that will qualify as a 4. Now, I can give you an example. If you use intents, okay, but you're using it to start up another app, or you're expecting a result back, then you probably have a callback in the starting activity to say that, okay, when the other thing is done and with a result, I want to know about it. That's a callback. That's a combination of callback and intent, and that will get you to the 4 out of 4 points. So it's not really difficult. It's just that you have to structure your code to utilize some of these features. And as I said, if you use processes or threads or intents in any other way that is not listed here, let me know and I'll put it into the right spot. Design mobile applications that utilize the user interface. I cannot imagine anyone other than people who do not turn in anything will get a 0. 0 means there's no user interactive components. 1 means only simple user interactive components with no interdependency of such components. In other words, when you click a button, it doesn't do anything to everything else on the screen. You press a button, nothing happens. Absolutely nothing happens. There's no update of any kind on the screen. So that would qualify for 1. 2 means only simple user interactive components with interdependency of these components. You press a button, a counter increments by 1 on screen, and the end user can see it. That's a 2. A 3 means the use of more advanced interactive components. If you use a list view, use a canvas of any view. If you do any type of subclasses of any type of layout, etc., that will be a more advanced interactive component. And the 4 means the use of complex interactive components. That would include any use of a surface view, which is automatically doing something with threads, with all kinds of other stuff, most likely subclasses and so on and so forth. if you use a camera or any other sensors for user interaction, like you're monitoring, shaking and movements and stuff like that, that will qualify for a form. Is that okay so far? I mean, if you guys have any questions, like you did something, it's not falling into any one of these described categories, just let me know and I'll put it somewhere onto here. Okay. Any questions?
So there's no requirement to use all those Android supplemental files and be ready for internationalization and
Nope.
strings?
Nope. Yep. This class is supposed to be intermediate with a co-requisite of cisp360. So I think this is good.
Good.
This is appropriate for the level of class that this is. All right. If there are no questions about this, I also have some other things to talk about. It's not very long, but it's just what I think is going to happen to the future. Not that we're all interested in knowing what is going to happen. One thing is almost for sure is I think most mobile apps or mobile computing is going to be increasingly cloud connected, which is kind of interesting because we're going the other way again. Okay, we started off with mainframe computers, right? And then dumb terminals that are hardwired to the terminals. Okay, they even look like typewriters in the earlier days. And then we went to PCs, and they're all completely independent. The only way you can get something onto a PC is a modem, which was somewhat rare back in those days. And then floppy disks was the main way of putting something onto a computer or getting something out of a computer, other than a printout. And now we're going the opposite way of getting back to connectivity to the cloud, which I think is kind of interesting.
Slightly smarter dumb terminals and a very smart back mainframe,
Yep.
which is the cloud.
I read one article, since you mentioned about the back end, what is actually the hardware that is powering up the cloud. I read about this article. Okay. I think it's possibly this one, but I was reading an article on how much investment Google had made in terms of hardware, because people think about Google and go like, oh, it's a search engine company. Okay, so they have no interest whatsoever in hardware or putting any custom hardware in the company. And that cannot be more wrong. Google is interesting. They have their own license to be a power company, so they can potentially have build their own power plant and even sell power to other end users. But they only got that permit so that they can potentially build their own power plant to power up their data centers. When it's too expensive to buy from Pacific PG&E, they can just build their own power plant.
Just pay for the fuel.
Yep, just pay for fuel, or if it's solar based or wind based or whatever based, they may or may not have to pay for fuel at all. But that tells you something about what Google is planning for, because it's not really a software or search engine company. That would be Yahoo. There was also a news with Yahoo that Marissa, what's her last name?
Mayor.
Yeah, she is getting out of Yahoo with a $100-something million severance package.
At least she doesn't bring the baby to the office anymore. She had a nice job.
She left Google for that Yahoo job because she felt that Google was not using her talents, I guess. But I cannot think of why she would be leaving Google. And now that she's done with Yahoo, she got a $100+ million severance package, and it's not for a job well done either. That was part of the contract when she got over to Yahoo. Regardless of the reason that she is going to resign or be fired, this is your guaranteed severance package.
You got to learn to read your contracts well.
Yep. Or have somebody to help you craft it.
Absolutely.
Yep. So Google is one of the largest hardware makers, and I think the key point is they made a lot of purchases and also their own inventions when it comes to neural net specific hardware. We talked about that a little bit in this class already.
So did they buy the Motorola phones? They must have. 12.5 billion.
12.5 billion acquisition of mobile phone maker Motorola. So they bought Motorola, which is actually pretty smart. If you think about it, it's
Motorola's good.
the Moto phones, still remain as one of the more reliable platforms, and I think it had to do with Google is directly behind it. So the kernel code, the driver code tends to be more reliable. Even though sometimes I think Moto phones can be kind of a little bit behind the curve when it comes to using the latest version. They actually build servers in the factory that actually make Google one of the largest hardware manufacturers in the world. And they know hardware, even though they don't sell their hardware. We know about flash, we know about equipment, we know about supply chain. We're well equipped from the hardware side to be very competitive in that space, because the point is we're consolidating all the heavy duty computation into the cloud. So your mobile device doesn't have to be very smart anymore. It's not like your PC back in the days of when PCs were king. Okay, you want the top end processor, 16 core, and then 16 gigs of RAM and stuff like that. Your phone doesn't need all that if it is cloud connected and you have good connectivity to the cloud or to major computation devices in the cloud. Your phone doesn't have to be very smart. Okay. So I think this is representing some changes that we'll see in the near future. The only part that might be slowing down this trend is Wi-Fi or 4G or 5G connectivity, because you cannot use this type of approach unless you have reliable high bandwidth type of wireless connection. But to most of us, especially in the Bay Area, where Google is located, okay, that's a given. Okay, it's a give. It's almost as given as electricity.
And it's going to extend year after year after year.
Mm-hmm. So it's going to be. This is going to be the trend. I think it's going to be the trend. Is a lot of intelligence, a lot of computation will be done in the cloud instead of on your phone. Which opens up some other possibilities as far as your phone is concerned, because it doesn't have to house the hardware to do all the actual computation. With your phone, I can see that this will be a trend, okay, depending on how fast we can get the components to make this happen. Is the user interface unit will eventually be separated from the quote-unquote main unit. In other words, there won't be a screen anymore. Whatever the main unit is can be maybe a quarter or maybe half the size of a real phone. Because if you just imagine without the screen, okay, which is a pretty good chunk, okay, of the actual mass of a phone, it also consumes most of the energy as well. Okay, if you look at how much of the energy is consumed from your phone, the screen does consume a lot. And it has to do with the inefficiency of an LCD screen. Okay, we talked about that last time. Only 1/10 of the light is going through when you look at a bright white pixel. Okay, so I can see the separation because the main unit can now be easy to pocket. Okay, because it's not this big anymore, and it ties into the next line as well. VR and AR in the near future, because you can basically just wear the interface. Now, what we see now in stores, with all those VR, rigs, that's first generation. It's almost like the first generation of laser printers. The size of this cabinet, and pretty slow. And how much do we pay for a laser printer these days? You go to Fry's and you want to pick up a monochrome laser printer, not one of those color ones. $70, $60, even $50 when they're on sale. Okay.
You want to get the one that's the big toner cartridge. Don't get those little toner cartridges.
Yep.
They'll get you, and what is it? The razors are cheap, but the blades are expensive.
Yep.
I found one that had like 1,000 sheets, paid 70 some bucks for it.
Yep. Yep. And if it breaks, you'll just get another one.
That's sad. Disposable planet.
Yep, but that's where the UI, I think that's where the user interface is going to move to. Is it's going to be just worn like glasses, but it'll be very light. That technology has been around for a long time, because if you think about 1080p resolution, you think about big screens, you think about at least 20 inches and stuff like that. But when you are using projection technology, the actual device emitting the light at that resolution doesn't have to be big nor expensive, because each pixel is so small. Okay, they can make out of one single wafer, instead of your entire monitor is one single semiconductor device. Okay, the screen itself. So it's very expensive because the yield is low, because yield has to do with defects per square area. Okay, per area, and that doesn't really change much. So that means the larger the screen, the lower the yield, because the likelihood of having a dead pixel is higher. But when your device is only about this big and is a 1080p resolution device, the yield is going sky high, because the chances of a defect landing in that space is pretty small. So out of one single wafer, now you can get more useful or usable units out of it. And then you can use optics, so that by the time it projects into the eye, it is the same as what you would see with a projector. So it's all about the angle of view. Has nothing to do with the number of dots. It's always the angle of view, which means you're looking at a 1080p device. Okay, how much angle is it covering from your perspective? Okay, if it covers most of your vision, including your peripheral vision, it's good. You don't need a bigger device. Okay, you might want a higher resolution just so that the picture looks better. I was watching a documentary of how in the human eye, only one part of our eye has really, really high resolution. We just have the illusion that we have high resolution throughout the entire retina. Okay, so let me get to that part, because all of this stuff eventually I think will be connected. Human eye. Cross section. Okay, there we go. So one of these pictures will show that. It's a retina. Okay, that doesn't show. Maybe this one. I think it's this one here. It's the fovea centralis. But only a very small portion of your eye actually has the super duper high resolution. The rest of your eye, it has a lot of the black and white pixels. They are motion sensitive and they are low light capable. But the colored vision with high resolution actually occupies a relatively small area of your eye. So I can see, monitors, or not even monitors, but VR rigs where only a certain part of it has high resolution. But then you also need your eye tracking and whatnot, so maybe the entire thing can be high resolution. But regardless of the point, the power consumption of something like that uses projection mechanism instead of a screen mechanism is going to be saving a lot of power, because almost all the light emitted from the elements can now be transmitted into your eye with very little loss. Okay, so I think that is going to be the technology. It's just a matter of how do we connect the light emitting mechanism to the projection mechanism so that you can see what we want you to see. But I think that's going to be the near future, because we're already experimenting with a lot of this stuff at this point. It's just that they're very bulky, they're very hot, there's not a whole lot of ventilation, and you cannot really wear those things in the public because they're not exactly AR based. Now Google Glass is one of those things where you can just wear, because it's an AR device. Do they have a second version of the Google Glasses or something along that line? This is the original one, which basically has a projection mechanism to one eye and then has a camera also, so that there's a way to transmit that data back. This is probably where the electronics are all housed, including the battery. I don't know whether they have a newer version that has two, both projections onto both eyes.
Looks like it was discontinued in 2015, released in 2013.
Yep. The journey does not end here. So where is it going now?
Look up the future of Google Glass.
Magic leap. Well, that's because they were using it, in a way
Walking
that.
into restrooms and
Yep.
doing all kinds of strange things.
Yep. Yep. Immature adults. The social contract. Okay. So it's a social issue more so than it is a technology issue. But I think the technology is going to be, someone is going to figure out, how to make that happen in terms of technology from that perspective. But the technology piece is only going to be one little bit of it, because even if you have the device that can do projection onto both eyes and you can overlay reality on top of that, what are you going to do with it? Now you have the hardware, what are you going to do with it? You can't do much with it without a user interface, without the operating system, without the connectivity to everything else. So that's going to be, I think that's going to, whoever can get that first, Apple versus, Google, potentially some other companies.
So that's going to be voice recognition. You think we'll drive it with voice? Or?
I think there'll be some options. I think if the device has a camera pointing backwards to look at your eyes, they can look at your eye movement. They can look at which direction you're looking at. They can look at your pupil.
So we can change menus by blinking.
Yes. Not even blinking. I already have an idea of how this can be done. Because you can, if they can look at your eyes and look at your pupil and look at which way you're looking at, they can actually use triangulation and figure out what is the depth that you're looking at. In other words, in a virtual reality.
So as we focus on a button, it can click.
Yep. So your button would have a different depth compared to the actual thing that you're trying to actuate. So there'll be a depth difference, and then if the resolution of the camera that's pointing inward is sufficient, and you can train it so they can reliably tell the computer what is the depth that you're actually looking at, that can be a mechanism for clicking or actuating some kind of mechanism. And I think that's going to be nice because you don't have to blink, you don't have to click, and it's just a matter of looking closer versus looking further, which we are capable of doing, pretty easily. So I think that can be, a particular mechanism for the user interface. And you can kind of imagine that can be kind of nice too, because so let's say you're trying to drag and drop, okay? Okay, so in terms of drag and drop, how do you do drag and drop using just eye control without using your hands, without using a button, without using a touch interface? So what potentially can happen is on the side, you can have a palette of tools. And one of those tools is drag and drop. So you focus your eye and look at one of those tools, and then the system register and go like, okay, you want to pick up this tool, and then wherever you look, that tool will now be it will be along with your focus vision, and you just kind of extend the view, from that tool's depth to the depth of whatever you want to drag. That will identify, okay, this is the thing that I want to drag. Once it is dragged, once it's hooked onto it, you just have to locate where you want to drop it, and then change the depth perception again to actually drop it.
I think you should. The whole thing can pick up. The whole thing can inside your head. There's all kinds of communication you can deliver without using words.
Well, I got a part of that covered too. Because it is already doing it. I mean, we are already having some technology that can do a certain level of quote-unquote mind reading. It's not really mind reading. It's really just being able to recognize certain types of brain activity patterns. That's the best way we can describe it. But there are distinctly certain types of activity that you can distinguish from others. Now, I'm not sure about the responsiveness of this type of mind reading. Is it really slow and they can just tell your mood whether you're activated or not? But I think this technology is going to improve over time because there's a lot of potential in this type of thing. They sell devices like that too, as toys. Okay, there's a Jedi toy mind reading. I'm pretty sure we can find something like that. There you go. Not a very highly rated toy, but somebody tried it. Force trainer. Okay. So mind reading toy, Star Wars, Jedi Master with hologram. That's not it. There we go. Okay, I'm gonna pause here and turn on the audio. Because these things do not seem to have anything to do with mobile devices, but I think they have everything to do with mobile devices. Okay, so there we have it.
Tablet on top of this prism. The headset reads your iPhone user can play against someone with an Android app. The Star Wars Force Trainer creates a hologram projection when you place a tablet on top of this prism. The headset reads your beta brainwaves, so if you concentrate just right, you can lift the X-Wing out of the swamp or push back your enemies. I am on my way to being the Jedi Master. Moving along here at Toy Fair, this is the I.O. Hawk. It's an intelligent personal transporter. To move, all you gotta do is just lean back and lean forward a little bit, or if you're like me and you're wearing heels, you have to really use your core. 6.2 miles an hour is its top speed, but I'm afraid to actually take it there. Move over, Easy Bake Oven, because there's a new high-tech oven in town by the Girl Scouts. In this new Girl Scout cookie maker, you're able to make your own cookies of your...
So you can now have the Girl Scouts sitting right at the entrance of Walmart. So they're not gonna promise you that, oh, we will take the order, we'll sell you these boxes. They can make your cookies as you wait. You can even use your mobile app to order your cookies ahead of time. So by the time you get to Walmart, your cookies will be ready. But I think this one is kind of interesting. The Force Trainer, it's a very toyish kind of thing, but they have to have some kind of scientific basis of doing that.
From Star Wars Science comes the Force Trainer 2 hologram experience. Now you can move holograms with the power of your mind. Reenact famous Jedi scenes as you develop your powers of concentration to complete incredible Jedi challenges. The wireless Bluetooth headset uses real brainwave technology to read your concentration levels and send a signal to your tablet on top of the base. The more you focus, the more the concentration meter rises, causing the hologram to move. Advance from Padawan to Jedi Master through 10 stages of Jedi training, powered by the Force Trainer app. Move a Jedi training remote. Raise an X-Wing out of the Dagobah swamp. Battle against droids, and more.
Stop where you are.
with Star Wars music, sound effects, and instruction from Jedi Master Yoda.
Tested, you will be.
See if you can complete all levels and become a Jedi Master. And learn about Star Wars holograms and real brainwave technology on Earth. Discover the science of Star Wars with the Force Trainer 2 Hologram Experience from Uncle Milton.
May the Force be with you.
Ooh, cool. Well, I know what I'm gonna spend the paycheck of this month on.
You didn't see anybody in there any older than like 12.
Well, they may not. The
thing
helmet may not
fit.
fit my big head. Yeah. But that's okay. I'm pretty good at hacking stuff, and with epoxy putty from Harbor Freight, I can do anything.
A little bit of duct tape.
Yep. Yep. But that combined with a projection, screen, that can be, a really interesting next generation device. Oh, the other thing that is kind of be
It's definitely an active area right now. The whole vision control thing. Yeah.
yeah, but vision combined with not mind control, but combined with brainwave activity monitoring, that can be a pretty interesting combination because now you have multiple sources to actuate and have your computer to try to figure out what you want to do, and only based on visual stuff. So you don't have to click, you don't have to touch. And combined with self-driving cars, I can see a really kind of interesting future, for a lot of different things. Okay, so one more thing, a few more things here. Integration with other stuff, the Internet of Stuff. Probably has a lot to do with mobile devices. As I have already told you guys, probably several times, I have a Ring for monitoring who's at the door and stuff like that, connects to my mobile device. I have several tiles, okay, so I don't lose track of stuff. I can tell where my son is because he has a tile in his bag, in his flute case, okay, because he tends to misplace his flute, and it is kind of expensive, so I just put a tile in his flute case, so I can actually tell where he is. So that's tile, that's Ring, that's Fitbit, okay, the integration with other stuff will only increase over time. I have a Smart Things, which is a Samsung hub for connecting to home automation stuff. Okay, so that's also an app, so I can actually tell, oh, this window is still open. I can tell, this motion sensor is tripped, and I can remotely turn on and turn off stuff. Okay, and I can see that being, another area where mobile devices will go is it will start to integrate with many other things.
So would you consider your Ring a mobile device?
A Ring itself is not a mobile device,
Because
but
in order to be mobile, it gets to move around from place to place.
But I can see that being a possibility. In other words, instead of having stationary security cameras around the house, you can build a track, a monorail track, so that you can have like 2 or 3 of these devices, and they're just kind of on patrol and moving from one spot to another spot along the day. So that can lower what it can do is to lower the price of a entire house surveillance solution, because instead of having to install like 16 cameras to cover every single angle, you can now have these things to kind of travel to kind of scan around the house. And who knows what else you can do with that monorail?
The new thing for honors.
Well, you can hook it up with a paintball sentinel. Look that up on YouTube. It is a lot of fun to watch. Somebody automated a target acquisition and tracking mechanism with a webcam and hooked it up to a paintball mechanism. So basically anything that moves across the view of the camera, it will track and shoot. Now you might think, how good can that be, right? Well, that thing, the guy threw a basketball, across that thing, and as the basketball was bouncing across, it got shot. So it can track fast enough, or possibly using predictive mechanisms to track and shoot a basketball that is bouncing across.
Yeah, it'd have to use some predictive
Yep.
if it wants to hit the target.
Yep. And it was only paintball, so it's not like, super dangerous.
No, that was the cheap version.
That's the cheap version.
The other one's called flanks.
Get an upgrade, right? But some of these airsoft guns, I was watching it last night, they're capable of 25 rounds per second with airsoft. 25 rounds per second. Now, they're not really fast, and the projectiles are relatively harmless for the most part, because each one is 0.2 gram, which is not heavy at all, but it's about 6 millimeters, as a ball. So it has a big surface area, it's relatively light, and the material is designed to break apart when it hits something that's harder. So it's not, going to be penetrating and killing stuff. But it's still kind of impressive to see a toy gun, shooting at 25 rounds per second. You can see like a stream of these, BBs, plastic balls, going across the room.
Yeah, I mean, we're running, 30 frames per second on a lot of this stuff.
Yep. Your eye can only see like a stream. You cannot see the individual balls anymore, even though it's pretty slow. They only go at 250 feet per second, and that's the Japanese limit on how powerful these guns can be, because they're supposed to be airsoft guns. So
Soft being important.
Yep.
Pick that speed up, it'll get a lot harder. Big stuff.
Well, a lot of people do modifications so they can actually go beyond that speed. Custom hardware. Now, this is the part that kind of interests me the most. Is the mobile market in terms of how many devices are actually sold, it has probably outpaced PCs, laptops, and tablets for a long time already. In other words, when you look at how many, the volume of the sales of mobile devices, it's probably, I'm just guessing, 4 or 5 times, of the PC market. Okay.
Which devices? Which devices?
Cell phones.
Cell phones? Oh yeah, absolutely.
Yeah, cell phones and smaller mobile devices compared to like desktop or even laptop computers, I think they're outselling by at least twice or 3 times. Which basically means they have the leverage, the quantity leverage of having ASICs. Instead of using even an ARM core, they can potentially use devices that are just specialized for mobile devices. And I personally have some experience with FPGAs and programmable logic, and I think they probably still want to have a small core that is just traditional, but the other part can be programmable in the field, so they can specialize the processing of certain things. And that has to do with sensors as well, like processing the feedback from cameras. If you use a single general purpose processor to do image processing, that's going to be slow. I mean, there's no way that can be fast because everything has to go through one single funnel as a bottleneck in order to do all the processing. But if you have an FPGA or some sort of field programmable device, then you can kind of reconfigure the processing capability to do visual processing when that is what you need to do, or audio processing when that's what you need to do, and you can do basically on the fly reconfiguration of the processing resources to make it more energy efficient. So I think that is a possibility with mobile devices. With Android, not Android, but with Google being so invested in hardware technologies, I think the chances of Android actually, Google actually taking some of the technology from the racks to mobile devices, I think that's a pretty good possibility that they might end up doing it. And now that they own Motorola too, so I can see all of these connections, all the potentials of these things happening. 3D vision from your wearable devices like Google Glasses, that's going to be almost a must, okay? Because if your wearable device is not only projecting input so that you can see what is projected, but it can also has like cameras to see what you are seeing, that has a lot of applications. because that one, for one thing, it is required for augmented reality. Because with augmented reality, you have to overlay things correctly so that the lines match up with whatever you're trying to overlay. So you need that camera to kind of at least guesstimate where do I draw those lines. But once your device has 3D vision instead of just 2D vision, it will have depth perception, which means it can virtually project a keyboard in front of you, and it can see where your fingers are. So when you type in the air, it can recreate the experience of actually typing on a keyboard. But I can see all of those things being things that are entirely possible with this type of devices. And the power source is the other thing, because you don't want to have to recharge your devices every 6 hours. That is really inconvenient. So the more sustainable way to do it, and this is not for environmental purposes, but just to be lazy so you don't have to hook up things to be recharged, is one part it can be human powered. Okay, we talked about this last time too, with the offset weight along an axis, and you can use a generator to do all that regeneration of power. Cordless energizing, we have those already. I think with your phone, a lot of newer phones, you can put it onto a inductance type of a recharging device, so you don't actually have to plug in your USB cord to charge it.
Yeah, the toothbrushes.
The toothbrushes, yep.
Yeah.
Toothbrushes are kind of special because they have a cradle, so it's really hard not to align it correctly. A phone is a little bit harder because it's just a flat surface, right? But I can imagine, like in the school, the chairs, the desks, and whatnot, that they all have hidden inductance, charging capability. But that might cause some other problems too, because inductance is magnetics, so anything that is magnetic will be disrupted.
What do you mean by LiDAR, though?
LiDAR is
That's the driving radar, right?
the driving radar. They are actually in the process of making inexpensive and very, very small LiDARs that is chip-based. You can kind of look at that as an extension of the DLP technology, the digital light processing technology, where they use electronics to actuate tiny little mirrors on a chip. It's solid state, but they're using that to control the, they use these in projectors.
LiDARs? Or DLPs, yeah.
Yeah, DLP LiDAR.
So it's light detection and ranging, yeah.
Yep.
Because I saw one of the first Google cars about 4 years ago. There were cameras all over the place.
Yep.
And now you have the Tesla with very little.
Well, Tesla is kind of like the iPhone of cars. They know how to package things really well.
And they make a lot of money selling all the components for other electronic cars.
Yes. They have been selling that stuff to, let's say, Smart Car for Two. So the E version of the Smart Car for Two uses Tesla technology.
So does the Toyota, so does the...
Yep.
Yeah, they're the one that makes the brushless motors.
Yep.
Yeah, they're not just a car manufacturer, they're building all the components. They actually passed Ford in market cap.
Yeah, with their newer $30-something thousand Teslas, they are challenging Mercedes and BMW combined. And they're not really only challenging the hybrid / electric versions of those 3 Series and C Class. They're challenging the entire 3 Series plus C Class with these new Teslas. Elon Musk, had already talked about how he planned to ramp up the production of the least expensive Teslas. And and they're already buying a lot of robots. You can read it up online as well.
Oh yeah, they're robot factories.
Tesla manufacturing robot ramp up. That's from last year. People actually saw delivery of these newer robots for manufacturing to their factories. So they're already ramping up their manufacturing facilities to ramp up the production of the, cannot remember the series of the new Teslas.
The X? It's the Tesla S and then the Tesla X.
But these are the new ones, Model
Model
3s.
3s, yeah.
The Model 3 is going to be the main part because not a whole lot of people can afford the S series or the X series because I think they're still pretty close to the $100,000
This was supposed to be
range.
the E series, but they turned it around. We did the Model S, EX.
But the Model 3 is supposed to be at the same price point as the C-Class from Mercedes and the 3 Series from BMW. Except these are all electric cars. And if you look at the 0 to 60 in less than 6 seconds, the S-Class can do it in 3.
And the dual driver, blah, 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 is like 2.8 or something.
Yep.
Yeah, that's with no shifting.
Well, that's
So
why it's so
plant your
fast.
head to the back,
Yep.
and that's it. There's no
Yep.
none of that.
Yep, and that's why they can out accelerate Porsches and Corvettes, because those still need some kind of transmission because it's a gas engine.
That little delay is enough
Yep.
to kill anything.
Oh, the manual shift is already proven to be slower than dual clutch automatic shifting. That's just no comparison, just because of the mechanism. Because when you are using a manual shift, by the time you press on the clutch, you have to let go of the gas, and then you have to. So that time lag is actually significant. A lot of people, have. It's proven time and again that manual shifting cannot match automatic transmission. Especially with launch control, there's no match. you cannot make a manual transmission go faster than an automatic transmission that is tuned for performance. But is it as fun? No. A lot of people actually who have there's a one YouTube video on 2 guys with the BMW 4 Series. And one guy had the manual transmission, the other guy had the dual clutch automatic transmission. So at the end of the day, after testing everything, they concluded that there's no human way to beat the dual clutch mechanism in terms of acceleration, launch control, and all that stuff. But it is not as much fun to drive. So the guy who bought the dual clutch said his next car is going to be manual shift, just because of the experience. It's just a lot more fun to drive, even though it's not as fast. So fast is not the most important
criteria,
part.
yeah.
Yep. So it has got 250 miles of range, seating for 5 adults, and the price tag is $35,000, which is a little bit expensive. I wouldn't buy a car that is at that price range, but this is only it's only going to be time before it gets down to like 20,000 range and then below and so on and so forth. I think that we'll be seeing changes in the next 10 years or so.
They won't actually come down, but the cost of inflation will go up, and it won't rise as fast.
Right.
Yeah, it doesn't rise as fast as inflation or something like that.
Yep.
And coming down.
But if we're only going to charge these cars using coal-fired generators, plants, it's not going to save the environment.
Don't call it green.
Yep, it's not. In fact, it will be less green than gasoline or particularly liquefied natural gas.
Because of the energy loss, just traversing the wires.
Yep.
I mean, that's such clean energy, but it has a major reduction.
Yep. But if it's solar based, then you have a pretty good argument and say that these are potentially cleaner. But solar
I think
panels,
hydrogen based is going to be solar based hydrogen plants. I mean, they'll all get unloaded. I mean, you fill up your car, it'll take 24 hours for the thing to fill back up again. If you have enough of those things peppered around, hydrogen might work out pretty good too.
the hydrogen highway was a Arnold Schwarzenegger project. So after he left, the EPA, the Cal EPA, everybody who did who were doing hydrogen highway had to be diverted to do something else. Because I think Arnold's vision did not anticipate distribution. So how are you going to distribute hydrogen as a fuel?
You can actually make it at a local station.
Yes.
I mean, just splitting, but it'll take a while.
It'll
Other than
take
that, you can put a whole bunch of power into it and do it relatively quickly.
Yep.
But that's not saving anything.
Nope. So he didn't really kind of factor that in when he pushed for the hydrogen highway. The best technology for electricity generation, the cleanest, is actually kind of semi-mechanical, like windmill. It's water, they're actually more environmental compared to solar panels. Because the manufacturing of solar panel is not clean at all. I mean, it's not green or clean.
And it's highly inefficient still.
You also lose efficiency over time. Solar panels have a half-life of about 20 years, which means in 20 years, the efficiency of your solar panels will be at about 50% compared to when it was new. It is inevitable because it's semiconductor based, so the material inside the semiconductor actually migrates over time. And as a result, it loses the original property over time.
So when we throw these things in spacecraft, they're got a shelf life.
They have a shelf life. Yeah. It depends on how you make the electricity. If it's based on the PN junction, then it definitely has a shelf life. But you can utilize solar energy for power generation using some other means. There's a place, I think this is interesting too, the solar generation using molten, I think it's sulfur, okay? Molten salt, okay, there you go. So this is actually very interesting. This is getting back to using, let's say, nuclear plant to boil water, and then we use the steam to turn turbine. It's the same kind of method, except they use solar energy to melt salt in order to store the energy, and then they just use the turbine. They use the heat to boil water, and then they use the steam to turn the turbine. But the nice thing about, go ahead.
Isn't that the one that kills the birds that fly through it? Because it looks like they were doing reflections and concentrating the heat, and then the bird flies through it.
But even with your wind turbine, people claim that when birds fly through the
tiny
blades,
ones that went really fast.
Yeah, they can also kill birds.
Yeah, so they made them really big and slow.
Yep. But this definitely will cook a bird.
These are highly. It's a great idea, but the birds don't know it's coming. So they're concentrating the energy up, right?
Yep. So they concentrate energy to this tower where the salt is molten, and then they have a mechanism to do a circulation. So there's a reservoir of the molten salt, down below ground. So the idea is you can retain that energy overnight, so you won't lose the capability to generate even when the sun has set. The more interesting part about this technology is the origin and who's funding it. I think if I remember correctly, the one of the people who funded these projects was from the Middle East. Somebody in the Middle East was smart enough to think, oh, oil is going to run out. It has to run out at some point. So it's time to use the money made by selling oil and invest that into renewable sources of energy. And this is actually one of those particular projects. So it's kind of interesting, how they're not using semiconductor. They're using using the solar energy as a source to collect the heat, and then use the heat to boil the water, and then use the steam to power up the turbine.
Yeah, we really haven't advanced much, have we?
But that's
we've been doing this technique for over a century now.
But they may not be, but they may still be more efficient compared to solar panels. But that's the whole point: is what is more efficient. Whatever is more efficient is just what we're going to use. And this technology also has a very little reliance on semiconductor technology too, because it's all kind of mechanical / chemical thing. So it's not a high-tech approach. The only high-tech approach is going to be the changing of the angle of the mirror, because they have to angle it every minute or so that they keep aligning to heat up the stuff at the top of the tower, which is here. But if you're talking about killing birds, it's probably only around a fairly small area where it is concentrated enough where birds can be cooked. But along the outer perimeter, it's just going to be slightly warm, if any.
You need multiple mirrors to focus, not just one mirror. Although one mirror could be pretty hot too. But yeah, as soon as you get the concentration, you're in this area, it's one mirror. Then get a little bit farther out, you're getting hit by two, and then
I think these
Or
mirrors are
A.
flat. Each one is flat, so it's not concave. Each mirror itself is flat because the target is pretty big. I mean, because the sun is almost the rays from the sun is almost parallel. So if you have a mirror that is 1 meter by 1 meter, the projection onto here is going to be about 1 meter by 1 meter. But this thing is actually much bigger than 1 meter by 1 meter. So it's okay. I mean, you don't need a concave mirror to concentrate at that point. So this is an interesting technology. I first looked at this one many years ago, and I'm pretty sure it is already in production. So getting back to this class. So I don't know how much you guys want to do with mobile devices. Like after this class, these are all crazy stuff that might happen in the next 5-10 years. But I think if you stay with mobile devices and mobile computing, I think there will be a lot of possibilities, a lot of opportunities in this type of programming. Oh, this one that we have not talked about, gateway to cybernetics. Because the ultimate mobile computing is full integration with your brain. So as it progresses, we're talking about 50 years probably here, to actually have cybernetics that you can actually purchase and put into your brain and whatnot.
Probably first you'll have to find a helmet that emits a signal.
Well, like that game thing, the Star Wars thing,
Yeah.
But that technology has advanced over time as well. I can't remember exactly how they do it, but in the medical world, in terms of psychology, and research in psychology, they use CAT scan, because what they do is they look at how much blood is flowing to which part of your brain. And that pattern changes, as you think about different things or as you experience different things. So I'm not sure about the technology in those toys, how they do it, but they're using some kind of outside observable quantity in order to try to figure out, what your brain is trying to do. But I'm pretty sure over time, that technology will definitely advance. And that will be a really kind of new interface to mobile computing, because you don't need to type something anymore. I mean, if the brain can tell, if the device can tell what you're thinking, or at least to the point where you can consciously control how you think, so that you're saying, okay, I need to search for this word, and you don't have to type, and the computer can actually tell from your brain activity that you're looking for a particular word, that will change the whole game. And if that information can also be fed into your brain directly without going through visual or auditory means, that will change the whole game as well. But that's going to be like way, way, way in the future. How do you inject the signal back into your brain?
That's the Matrix, right? Plug in and download flight programs for a Huey helicopter. Okay, I'm ready.
No, we'll have Bluetooth by then.
Remember the Matrix? They had you saw two views of it. One without the plug-in,
Right.
But the other one was when they wanted to download stuff. They really jammed it right in the back of their head.
But I think that's going to be. No, they didn't show the actual technology, but I think the actual technology is they have one kind of like a adapter, just kind of installed, at the back of the brain. So that jack is really just downloading a new program to that interface, because I cannot imagine that you can actually reprogram the brain itself, in a very short amount of time. That is just not easy to do.
Well, there they would really be running an augmented reality, because all these guys were, in particular the Matrix, nobody's there. They're all
Right.
sitting in a tube.
The virtual reality.
Everything
not even
else
augmented.
is virtual.
Right.
So it's intense.
So they have full interface to that, but how we perceive reality is based on our senses, right? And that is relatively easy to figure out, because once you figure out how a heat sensor works and how it transmits that information, that probably can be emulated with ease. What is difficult to figure out is how we think. How do we formulate the concept? What is red? How is the concept red represented in our in all of these synapses, right? And how
Oh,
you
yours
represent
similar to mine.
exactly. So that and also learning new things require basically forgetting old things. Okay, that's how your brain works. Okay, it cannot just keep on taking in new information. At some point, it has to lose things in order to kind of not get overwhelmed. So that cannot be done over time. So I think the quickest way to download knowledge is really to have a constant interface, so that when you're consciously trying to recall something, that part just connects to the computer, so you're recalling facts easily, but how your brain works will still be the same. I think there's a separation between how you process as opposed to just knowledge. Knowledge is just facts, right? What is the Earth's gravity? 9.8 blah 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 blah. Feet meter per second squared. Okay,
That's what it
that's
shows
just
up on.
facts.
That's how I know it's flat. Right? The gravity on the
Yep.
z-axis is,
Is that amount? And you also have
And then
to
I know I'm
supply. Yep.
So I took from back in the program. I'm doing all the orientation stuff. I don't want my activity killed, so I'm going to miss one point there.
But-
I don't kill my activity. I let it live.
Yep. But the way you think and the way you actually process the information, that's a lot more mysterious. And also how intuition works, and how does your brain automatically make associations, between things without even really consciously thinking about it. Your subconscious is much more powerful than your conscious mind.
By far.
It's kind of like the iceberg, right? So what you see as yourself is really the tip of the iceberg. Much of the processing is happening down below the surface. And we have no idea, or very little idea, of how that part
I
works.
saw one, like when they did this, you brought up the CT scan, but they did the one that when they, all the stuff's changing. So when they take the CT scan, the constant slices, that's one slice in time.
Yep.
But if you watch that same slice over time, you'll find that it's changing and morphing its shape too.
Yep.
So kind of makes all this stuff confusing.
Yes.
Yeah, we don't know much about it at all.
Nope. Until we can actually insert your probes or mechanisms that can monitor activities at the synapses, and also monitor, because the encoding of information, as far as we know at this point, is chemical based. It's not electrical. There's nothing electrical about our brain. Even the transmission of signal from our nerve endings to the brain is not electrical. It is chemical. And that's why it is so slow. It takes milliseconds, in order of milliseconds, to transmit out to your brain. Because it's chemical based. It's by inverting the two chemicals along the outer shells of your nerve out of your nerve. I cannot remember how that stuff is called.
There's the myelin on the outside, but then there's two types of nerves, efferent and afferent. Those that are sensing, those that are pushing, kind of.
Right, but the transmission of the signal has to do with a pulse that is just inverting the chemicals or the polarity of the chemicals along the way. So it's a chemical process, it's not an electrical process. Like most people think. Most people think that we are electrical, but it's not. So there is it for today's lecture. Are there any questions about your programs, your apps, your projects, anything that is holding back and go like, okay, I cannot get past this point? We got about 2 weeks before your final project is due. So if you run into any problems, in terms of programming or getting your app done, now would be a good time to ask. Anything? No? You all good? Okay. And you might want to go over the list of the grading criteria of the final project. So if you're doing something that is not on the list, okay, and you want to go like, but how does this factor into the grading? Let me know, and then I'll give you an answer and also add it to the criteria of the final project. So this way you can
How
kind of
about the
tell.
deviation between our proposal and our completion?
I'm not going to use that as a grading criteria, but you do have to
I
tell
learned all
me-
kinds of things as I went down. I'm like, I can see this thing go in this direction now.
I can understand
This,
that. It's
this
not a
is where I
problem.
really want to go. That was, before it was just PowerPoint.
Yep.
It's like, yeah, this makes sense.
And then on top of that, you also look at something that's doable now, whereas before you might think, oh, that may be difficult to do or did not occur to you that you can do something like that. So I can definitely understand, oh, you might want to morph or change your use cases because of the topics that we introduced in this class. All right. Well, this is the end of the lecture. I'll stay in the lab, for as long as you guys want to kind of talk about your program. If you have bugs that you want me to diagnose, we can do that. No? Okay. I'm going to turn off the mic and turn off the streaming, but I'll still be here